Dear friends, today I'll discuss with you the grouping of the capacitor. Capacitor can be grouped like series grouping, and there is a second parallel grouping. So first of all, I'm coming to capacitors in series. Okay, capacitor in series. Now, what is the definition? How we call that the capacitor are in series? Look, this is the diagram. First capacitor, second capacitor, third capacitor. And there may be a number of capacitors, but I have shown here only 3. Okay. Now this connection is going to add the earth potential. This plate is connected to earth. First, second, third. The second plate of the third capacitor is connected to the earth, meaning it is at the earth potential. And some potential is given between this end and this end, and let that potential is V. Because the potential is given, before coming to the derivation, first of all, what we mean by the series, when we call the capacitor, they are in series. Capacitors are said to be connected in series between the 2 points, these 2 points. When we can proceed from one capacitor from one point to the other, from this point to this point, okay, through only the single path. So there is only one path. You can go from this to this point. If they are single path, then capacitor, they are said to be in the series. Remember. Now some potential is given here. So this plate will get some charge. And let the amount of charge which is here, let we call it plus Q. Now what happened? This is our, these are the metallic plates and in the form of the English letter H. Induction will take place. Induction means inner side of this H construction, inner side of this H, it will acquire a negative charge minus Q, and outer side of this H will acquire the positive charge plus Q. Now again, because of this plus Q charge, there is another English letter H. Again the inductions take place. So inner side of this H will acquire minus Q charge and outer side acquires plus Q charge. Again, what will happen? Again the inductions take place, induce effect. Now there is no H, there is a single plate. The inner side will acquire now the minus Q charge. Outer side acquire plus Q charge, but plus Q flows to earth. So there is no plus Q charge, only the negative Q. So this is how the capacitors, they acquire the charge. Each plate, like the capacitor 1 plus Q minus Q, capacitor 2 plus Q minus Q, capacitor 3 plus Q minus Q, like that. Okay. Now because the relation between V, C and Q. What is that relation? Very simple. The relation is Vc equals to Q. Now these capacitors are of different capacitance, C1, C2, C3. The capacitance are different. Okay. But charge Q is the same. C is different, Q is same. So what it implies mean like V equals to Q by C. If C is different, V will be different. Even the Q is the same. So that means here the potential will be V1 across C1. Here the potential will be V2 across C2. Here the potential will be V3 across C3. Okay, we know very well the potential, it is a scalar quantity. Because it is a scalar quantity, that means we can write V equals to V1 plus V2 plus V3. Okay, because potential is a scalar quantity, you can write like this. Now substituting the value of, what is V1? V1 is Q by C1. And what is V2? It is Q by C2. And what is V3? Q by C3. So substituting the value here, so we'll get V equals to Q by C1 plus Q by C2 plus Q by C3. Now the whole, we can think equivalent capacitance, equivalent capacity of the three capacitors. Let we call it equivalent, we call it C series. CS means C series. Okay. Because charge is the same, so this potential is the equivalent potential across the 2 points. So potential across the 2 points, we write it again as Q, because Q is the same. Q by equivalent capacity of the whole system, which is CS. So it becomes Q by C1 plus Q by C2 plus Q by C3. So Q get cancels out. So 1 over CS becomes 1 over C1 plus 1 over C2 plus 1 over C3. So this is the resultant, the capacitor in series. I mean to say, if the two capacitors are in series, C1 and C2, then the 1 over C will be equals to, CS will be equals to 1 over C1 plus 1 over C2. That it is C1 C2, that C1 plus C2. Okay, 1 over CS. Or you can say CS becomes C1 C2 upon C1 plus C2. This is the formula only when there are two capacitors. Don't think for three capacitors like C1, C2, C3, C1 plus C2 plus C. That's wrong. This is formula only for two. For three, this formula is applicable. You apply this formula for three or more than three. And for two, you apply this formula. Okay. Now this result shows if we are having the capacitance 100 microfarad, and there is a second capacitor of the 10 microfarad. What about the resultant capacity? They are in series, connected in series. Then CS becomes 100 into 10 upon 100 plus 10. That is 1000 upon what it is, 110. Okay. So what about the result? So this ratio will be less than 10. The answer will be less than 10 microfarad. That means if the capacitors they are connected in series, the resultant capacitance, the result of the resultant capacitance will be less than the least value of the capacitor in the arrangement. As the least value is here 10, the result will be even less than 10. Okay, if there is 10 and 1, 10 unit and 1 unit, two capacitors, the result will be less than that of the 1 unit. So this you keep in mind for the capacitor in series. Whenever the capacitor they are connected in series, maybe like 1 microfarad, 10 microfarad, 100 microfarad, 3 capacitors are connected in series, the answer will be less than 1 unit, 1 microfarad. Okay, whatever the least value, the resultant capacity will be even smaller than that. So this is the whole about capacitors when they are connected in series. Okay.